Ciao guys, welcome to another video of my YouTube channel. So, is there any Naruto fan here who is watching this video will easily identify the building which I'm going to make in this video. So, this is where the Naruto Chunin exam, they conduct the exam in this building. So, I thought like why can't we make this building so that I can explain you about certain components, and this building is also something interesting. So, why not? And let's go into the video, and this is the model at last we are going to this is the output model we are trying to reach throughout the video, or like throughout the script which we are planning to do right now. So before we are going into the video, please press the subscribe button, which will be so helpful for me to do more and more videos. I hope these videos are helpful. I don't know, some people are asking some doubts on Instagram, so I'm happy for them, like at least they're trying to do so, at least like it is helpful for someone. So let's go into the new document. So in the last video I was telling, like at the last of the video I was telling to people, like I just gave some questions like an exercise. So as people like find out this one, like this is the question which I shooted out at the last, there's a list. I just want this list to be separated into 5 branches. Each branch consists of 2 items. Technically, this list consists of one branch with 10 different items. So I'll take the param viewer. So in this you can see there is one branch, and one branch has 10 different numbers. But I want this branch to be manipulated into 5 different branches with 2 numbers in each branch. Usually we can use partition list. So let's connect the list over here and give the number of elements which you need, and and you can see the list is been partitioned. But the base of all the component, like the base of all the data manipulation component starts from path mapper. Like even the flatten, reverse, graph, simplify, you can do this with just path mapper. So like I'm just connecting the list. So it's asking for the source, like the source is like I'm going to give A semicolon B. Sometimes I get confused as I use the list. So now I want to split this list into 2 for each branch. So what I'm going to do is like I'm going to create A, which is like 0, and the B, that is 0 comma 0. This B is like going to be like 1 2 3 4. For example, like in this list, I just create the script name I split by 2, then this. So if you see maybe I'll just connect this. So if you see, this is A, this is B. So this B, if there is another 0, then let's call it as C. So I want this B to be 1 2 3 4 5. So this B is like I'm dividing the list into how do I say, like each B, like each character of B should have 2 items. That's why I divided by 2 instead of B. So let's see whether it works. Yeah, see. So this is the A and B. So A and B is like A, B, whereas I is the list. So in the place of B, I want like 0, 1, 2, 3, 4, the branch. So what I'm going to do is I created that I is the number of the list, and I'm just splitting into 2. So each B has B is like the continuous number. So each branch B is like, we can say it as a branch. Each branch has 2 numbers. So 10 number divided by 2 is like 2. Okay. So this you can change the path mapper you can manipulate different data like different ways using path mapper. You can flatten the data, you can reverse the data, you can do multiple things with this path mapper, which is like a great tool, and this is the base for partition lists, sort lists, lot of things. So try to explore this much more times. Okay, so in this video okay, we just figured out like we created two, like we want like there was 10 numbers and we created evenly like 2 2 2. So in case if I want 1 for the first branch, I want 1, the second branch 2, third branch 3, fourth branch 5. So how do you create the hint? Like I already did off of this. So I created an event. So now you try with odd numbers, like multiple numbers of things. You might be asking, bro, you do the easy part, why are you giving us the tough part? No worries, next video I'll just give the answer for that. Okay. So you can wait, you can see in the next video for the answer, but mostly you will figure it out. Okay. So now let's go into the model which you're planning to do. So again, I'm saying please do the subscribe. Please press the subscribe buttons. It will be so helpful for me to post more content. So let's go into the video. So technically, we need to draw the dome. Okay. So like in Grasshopper, not only in Grasshopper, any model, let's have like point, then curve, then surface, then mirror. So point is like every points. So curve is like polyline, polygon, knob curves, everything comes under curve. Surface is like planar, coplanar, curve, tip surfaces, closed surface, and open surface. When it's closed surface, then it becomes a solid or a beer. Beer sometimes like multiple surface joined together, like it also comes under beer. Okay. So now you can create a curve with the help of points. You can create a surface with the help of curves. We can create a beer with the help of surface. The same way, we can extract surface from beer. We can extract curve from surfaces. We can extract point from curve. So this is how it works. Okay, like it is vice versa. So technically, when you at last we just like if you are like doing like for example, if you need a curve, at last you can either create a surface and then you can generate curve from the surface. Like for example, you create two curves and you create a surface and you create contour, so you get multiple curves in the surface. So there is a lot of ways to do. So basically, like a Grasshopper works in this way. Like the algorithm can be shuffled in different ways. So in this case, we are going to, it's kind of a dome structure. So we are going to try three circles. One like each circle, like this is like when we create this circle, we loft it, we get this output geometry which we are needed for. So we can like we can create this geometry with this curves as I said before. So first, like what we can do is we can create three curves and then we can move it. So for creating three curves, we need to give three different values, and for creating move, then we need to create three different values because it is moved in different values. So we are going to generate three numbers. It can be random, it can be range, and like anything for the move as well as circle component creation. So let's take the component which we are looking for, like the main component for the step one. Actually, this is a step one. Sometimes I forgot to say. So this is the circle which we are going to use to create a circle. Now we are going to generate numbers, value for radius. As I said, we are going to create three numbers. So you can generate a number through range or series. A list of numbers, or we have different like different components which can also generate numbers. But basically, we use range or series, like which is the like primary component to create numbers. So range is like you give start, end, and range and a number of values you want to create, so it splits evenly the number of values you give, that is range. So in this you can control the start, you can control the end. Whereas in series you will give the start, you will give the plus like the count, and I mean the step and the total number. So it generates like addition, like how much ever you give the step, it adds that number. So this is how it works. Right now we just need range because it has a domain. So domain is the major element for graph mapper where we are going to manipulate the data. So in range, when I give like 2, I get 3 numbers. So technically, like in step is like as domains, so it considers like 0 as 1. So it gives me 3 numbers. So Or what I used to do is like if you want a particular number, you go to three, go to steps and do the expression. Expression is nothing but like take the x as an input value. So this is the x as input value. What you're going to do? I'm going to minus it with one. So whatever value I give, like for example, I give six, I give seven, it gives six numbers. So you see, like the value inherited in step is 6. So there isn't like a blocker or a expression is happening. So this value is x. It's automatically minus 1. So it's like 6 is here. So when I keep 3, it's because like when you use range, most probably we don't remember that every time we do. So like we just make it common with other component because sometimes you can't be remembering this every time. So with the number of values. So I always prefer to do this. So whatever number I change, it will be like it won't create a problem at last. It's a script. So by domain is saying 0 to 1. So you might say, bro, 0 to 1 is like so smaller. Actually, we can change the number. For now, we just like go with 0 to 1, which is like easy to manipulate, easy to explain to you. So this is the Bezier curve. So when I create a graph mapper, you say it's 0, 0.5 and 1. So it's standard, like it creates a start, it creates an end, whereas the domain start is 0 and this one, and we have only one in between, so it's the center value. So if you see, the value is been changing. Maybe I'll just connect it over here and I'll show you. I'll just like now I just do multiplication. So that's what I said, we can change the number. So we just need a proportion. Like this is the proportion which is going to manipulate. When you do multiply, it will be the same proportion but in different scale. So the scale will be done in proportionally. Like if I'm not wrong in what I'm trying to say. So you see, like there is only two circles. So let's. So we got the third circle. So technically the domain is 0 to 1. So 0 to 1, you can see the number. Okay. So technically this part in this, like in this vertical axis, this point states the start and this point states the end. And like this is like start and end. So this one is 0. Like this part of this map is 0 and this part is 1. So like 0, 0 0.1, 0 0.2, 0 0.3. So if you see, like the start is 0.3, you can go 0.4. Like it is split it into 10 squares. Like so that's why I said, like if I say 0 to 1, it is easy to explain. So this is how this graph mapper works. The same way this is the end. So for now I just, and these are the middle. So if there is like 10 values, then this curve is divided into 10, and wherever this curve is being intersecting with the graph, then that value will be manipulated here. So this is easy to create a shape which you really need it. I use graph mapper a lot of times, but it depends on people. Some people use vectors, attractors. So it's like totally depends on people's mindset maybe. Not mindset, like it's their options. Like that is the one way of thing in Grasshopper. One good thing in Grasshopper, like if I ask a class to make a pasta, so I write a script, write and steps for pasta. Each people make the pasta in their own way. Like at last, the final output can be like more beautiful. At the end of the day, we have like pasta, but when you look into carefully, we get different kind of pastas. So, and there are some different steps. So the steps doesn't matter for me. Like the software doesn't matter, the step doesn't matter. At the end of the day, the model which you are trying, the model which the client is asking, that is what steps matter. We just need to produce the model which they are asking. So like, why they're like, okay, graph mapper. I just created from range. Go with this here again because I said I need to move it in three languages, right? So I'm going to move this like this and like this and like this, okay? And I'm going to multiplicate this, like multiplicate, do the multiplication, like maybe why not 37? Well, 7 is my lucky number. I used to say this, like I sometimes blabber in between, so don't mind it about this. So I'm going to move this component. So I'm going to connect the geometry, the circle over here, and now I'm going to use this vector unit C. You might ask like why we need to use unit sector instead of that, why can't we connect here? See, this as a number, but we don't know the direction in which it should be moved. So unit Z is like 1. So when you multiply into A, so it will be A. So A is the value, it is a unit vector, so it has an amplitude of 1 and direction of and the direction. So we need the direction. That's why using a unit vector, so it gives the direction. So now what we are going to do, we have the 3 circles. Now let's loft it. If in case if it's not lofting, just flatten it and loft. Mostly it will be flat and it will be lofting, but sometimes if you do some mistake or if you're trying to do some other technique, it might not loft. Okay, maybe I just need this to be like little bit like this maybe. Yeah. So now we save it as a prep. Or else let's do. Okay. Now we got what I say. We got a loft. So what we are going to do is now I'm going to create like a inner surface, like an inner surface which is not like this circular. I just want it to be little flat like a cylinder, but a little distorted. So what I'm going to do is I'm going to use list item. So this is the list item. So I'm going to create another one and I'm going to reverse this so I get the top. You can already do this +1 so that you get start and bottom. So but right now I'm just avoiding that so that it might confuse you a little. Offset curve. I'm going to offset. So maybe like 0.4. If you see the curve is being outward, so I just need the curve to be inward. So what I'm going to do is I'm going to reverse the vector. So I'm going to use -x. So when I use -x, so the value goes inside. So the outside becomes positive and inside becomes minus, like the negative. Let's do it for the same, like for the base plane, but not the same number because I just wanted the base to be bigger. And let's loft it. So we got it. So let's keep this aside. Now I'm going to do cap to close it, to create a closed you can see like in this it's a closed beat up, and if you see it's untrimmed surface. So because I need closed beat up to create solid difference, solid difference if I'm not wrong. Yeah, so solid difference. This is the outer box connector and connector. So when I create, you get this shape which ideally makes, so the inner is like kind of cylinder which is being smaller in the top and bigger in bottom, and the outer is a proper dome structure curve. So this is what I was required, I was needed, so I created this. So I created. So now what we are going to do is we are going to create like if you see like there is a curve here, right? Like something similar we are going to create it outside. So we are going to create a frame outside of this dome structure, like the outside of the curved surface. So what I'm going to do is I'm going to first need a line. So for creating a line I need to divide this curve. So I'm going to divide curve, divide curves. So I'm going to connect this curve here. In the same way, I'm going to connect this here. So we got the curves and we got the points and we got the lines. So right now I'm just going to turn it off. So now I'm going to project this because the curve should be like this is the project. It projects like on the surface like a beat up. So I'm going to curve the line. So you see like this is the surface. I just want to project only on this surface. So I'm going to create a surface from drop and I'm going to join this if you see. Okay, so if you see like we got the curve which we are looking for that. So now let's close this. Let's have the curve. So now what I'm going to do is I'm going to use this curve. So now I'm going to create a rectangle in the bottom and I'm going to sweep it around the curve. So create a rectangle. Actually you can do with edge points, but it should be perpendicular to the curves because it's not a straight curve. What I always do is I create perpendicular frame. So this is a curve and it creates multiple multiple frames around the curves. So before that you see the curves, it's like it's in different branch, each curve is in different branch, but I just want right now I just to simplify to avoid this number of unnecessary zeros, like unnecessary branch you see like 0 0 0. I just simplify it so it's kind of cleaning the branch, or like just make it sure like you don't end up in like 7 or 8 branches, unnecessary branch and the end of the script. Okay, because like if you're planning to do like a lot of larger script cleaning, like make sure like you are doing the you are like sorting out the branch manipulation like in between so that you don't avoid the unnecessary like confusion. So right now I want a curve, a perpendicular plane at the start and end. So now I'm going to remove the multi-line data. So wait. So the length of the curve is like 27. So you might think like, bro, the start is like um, 27. So it has 27. The start is 0 and the end is 27. So why are you giving 0 1 0.51? So you know there is a term called normalization. Normalization is like if you have a curve of 0 to 100. So we can propose to scale it down to 0 to 1 the numbers. So instead of giving 10, you can give 0.1. Instead of giving 20, you can give 0.2. So this process is called reparameterization. So that's what we're going to do. We're going to reparameterize this. So when I reparameterize this, you see this curve is considered as like 1. So 0 is the start, 1 is the end, and we got 0.5 that is the middle. So this is how we work with reparameterization. You can use it in evaluate surface. A lot of things you use it for reparameterization. But this is a basic explanation of how reparameterization works. So now, as I said before, I'm going to create a rectangle. So you can see, like usually when you give like maybe 20 by 20. See, no, this is too much. Maybe 2. So if you see like when I look at 5 by 5 starts, the point is being starting from the end of the rectangle, but I just want it should be start from the center of the rectangle. So what I usually do is like I create a panel maybe for now, or else you can create a construct domain and do something like that. So I create a domain by myself. Like I start with the minus value and I end with the positive value. In this way, the rectangle is started from the center of the rectangle will be the origin of creation of rectangle. That will be more helpful. Maybe right now, let's create a value like this. That's not, as I said before, I actually did this model, so I just follow some values which I remember from the old model, because I did like multiple times to get the more get the value which looks similar to those buildings. So that's why I'm just following the same value. But you can check with different values. So I'm giving 0.4. So when I do this, like you can see, hmm, so you can see this rectangle is been starting. The rectangle is been constructed from center of the rectangle. So this is how we create from the center of the rectangle. Now I'm going to sweep 2. Sweep 2 is so sorry, sweep 1, because the curve is so simple and our branch is so neat, so it's not a problem. So the section is so simple, the rectangle and the curves of the edge. So why I create a plane? Because you see, like this plane, this gives me more creation. Like if this curve, like you can see the rectangle which we created is like perpendicular to the curve frame, so that's why I use perpendicular frame instead of directly sweeping. You can also do the sweeping directly. This is not a big complicated curve, but it is better to use perpendicular frame in this case, right? So that you will understand how perpendicular, you don't do a lot of mistakes. This is like a perfect page, so the value doesn't change when you do the sweep around the curves. So we got the sweep. So now what we are going to do, we are going to cap it. So now we got the out, like we got the inner structure, then we got the outer frame. Now we want to create a top similar like frame. So creating top frame is so simple. You select these two curves and loft it or like extrude it and then cap it. That is one better way. Yeah, we're going to do that, but in this case I'm just like a, let's take this curve. I'm just going to do a small change in this curve. Like I'm going to do offset curve so that the extrusion is a little bit projected outward, and then I'm going to use the inner curve for the other extrusion, like the offsetted curve, like you see, which I'm not going to change. So I just took these two curves and now I'm going to loft this, maybe I'm not sure. Let's try. And now you can extrude. You can do this, or like you can extrude, then you can cap it. So anything is possible. Like it depends on your process. Like, or else you can also create like ruled curves. Ruled curves, a curve surface is created from curves. So there's two curves. So it's up to you. You can do whatever you want. Like now I'm going to extrude. So I just connected, you might ask, so I'm going to extrude in which direction? I want to be in top direction. See the combo, like see the axis over here, axis like navigator. So I just need to see Z position, which is up. I'm going to create a unit vector. By default, unit vector has a value of 1 with amplitude of 1. So, but I don't need 1. I just need like maybe 0.06. Why not? Like a flat triangle. And if you want, you can also like we can also reduce offset like 0.05 or something. So it's up to you. If you want, you can create it more. It's totally up to you. Okay. I just create a beat up over here. So now let's. So technically now we have the top, we have the frames, so we can create some frames. You can also do solid unions here. You can cut out to make it more realistic. You can cut this part and connect it. So it's like you can do whatever you want, make it more detailed. Right now, I'm not going to do that. I'm going to create some solids here, maybe. Let's see. So now I'm going to, instead of creating divide curves, what I'm going to do is like I'm going to use curve, this curve maybe, the offsetted curve. Instead of using like this point, I'm just planning to use this point. I can divide the same with, like I can use this component. Instead of that, what I'm going to do is I'm going to curve close this point. I'm going to pull this point over here, pull the curve here. So you can see I'm just pulling this point over this to this curve, and now I'm going to create a 2-point vector. So this is like another way of creating the same extrusion. You can use the method on the above which I mentioned, but now I'm going to use to plan to create a vector using like creating the extrusion with the vector and the planes. So I'm going to connect this over here, and like I'm going to create a vector here. So like I'm going to show the vector what I'm trying to create. So this is a vector display, like the points I connected here. So you can see the action is over here. So this is how you can create a vector plane. So now I'm going to create, I just want not plane origin, I just want align plane, no, align planes, nope, okay, okay, I just want plane normal. So I'm going to connect this vector to the z-axis, and I'm connecting the point over here. So you can see the frames has been connected over the vector. So for the vector, it's been perpendicular to the vector which we have created. So you can see if the vector is placed in this way, it is like perpendicular. The plane is created perpendicular to the vector. So plane normal. So now I'm going to do is like you see the rectangle which we use. And like what I'm going to do is I'm going to take the top rectangle, the list item dash. So you can see the bottom is being selected. I'm going to do reverse so I get the top rectangle right now, and I'm going to create a curve right now to save this, and let's use project again. Project. Now I'm going to use this project. The project is like the curve on the plane. I want this geometry to be projected on this plane which we created. You can see the geometry which we created is being projected. But the problem is, you see, like there is a lot of elements being projected, because like there is like then flatten this, so you can see this element is being projected here. I'll show you why I did the flatten. I'll just take a panel. So it has a list of 10 numbers in a single branch. This one has a list of 10 numbers in different branches. So what happens is this number, so this is called data matching. This 10 numbers is matching with this rectangle. This 10 numbers is matched with this rectangle. When I flatten it, so now this rectangle matched with this data. So it's like linear matching. That's why I just flattened this. So data matching is another interesting subject of like a grasshopper. So now we have this curve and we have this curve. This curve should be flopped with this curve. So we have two curves. So what I'm going to do is like, I'm going to create a curve again. So technically, like if I loft this and this, it's like this. So it creates a single list. What I'm going to do is I'm going to match again. Like I'm going to create flatten. So see graph. I'm going to graph it. Maybe I'll just flatten this frame. Yeah. So what I did is like instead of grafting this, why I did flat because you can see this is in 0 and this is like as a 3 branch, like the indices of the branch is more. So we just need to match the branch together. And why I grafted it because like if I create loft with this, so this all polyline like should be matching with this. So instead of loft, I will show you another component. I use merge in this case. So if I use merge, like you can see, so it creates a single list. But in this case, when I graphed both the elements like this one graphed and this one graphed, so you can see this line, this curve has been matching with this curve and it creates a branch like this. That's why I created a branch. So these two curves loft. So I'm just manipulating the data in a way that it loft. It matches the curve for the lofting. Now we created what we want. And now again I'm going to grip. So instead of doing grip I need to do cap holes so that it is closed and we close this. Now let's open this. You see the connectivity which I'm trying to create. So this is how the detail is created. You can also do with the same process which I did in the top. So it's up to you. So you can see it's a small detail but it looks good like when you bake it. When you bake it and give some material it looks more detailed. So now the major part right now which we are going to create is like the horizontal frames. So the vertical frames are like kind of frame, like the subframe should be made and the horizontal frame should be made. The base of all the geometry is the curves. So what I'm going to do is I can use a curve here, but there's too many like the connections are there. So let's create the list item again. Let's check the geometry here. And now you see like this is the start and I reverse this is the end, but I want the middle one here, so I give the value of 1. So in this case if I add here -1 shows the bottom and like the +1 shows the top. So you can add the data like plus and minus. I just change this value. Okay, list item. I can give us a number or else I can delete this number and excuse me, I can set an integer here like 1. So it's up to you how you do the. You can input the value in different ways. So now we are going to create a offset of this on a surface. So right now I'm going to create the curve. And the surface which we are going to use, obviously the outer surface, like this surface. You might say, bro, it's a beat up. So actually, like for example, you can extract a brick over here, and you can extract a surface over here. So that's why I use params. So in case of they want a bit of, I use a bit of parameter to convert this. Like we can convert this as well as bit of, and from bit you can convert this as surface. So sometimes use the particular, use the exact parameters to change the values. So the curve which we like extracted from the list is being offsetted based on the surface as the reference as the plane. Like if you see like offset curve, it has plane. So instead of plane, we are using surface as the reference here. So it takes the surface as a reference. Right now, what I'm going to do is I'm going to use this curve which I created here. I'm going to flatten it and because there is only one curve here, and I'm going to flatten this again. And I'm going to change it to minus, so it goes inside. Now I'm going to loft this place, so you can see a loft like a surface has been created. Now I'm going to scale this, and I'm going to create area based on the loft, and we got the area to scale because we need a center for the scaling part. So that's why the geometry is here. Maybe the factor is like 1.016. Why not? You can see like most probably when the number when I'm trying to use is like mostly like the numbers of 7 somehow. I said 7 is my lucky number, so that's why. So I used a cap hole here because like the top with the cap hole I can do the top and bottom, I can close the top and bottom. So now I created a top and bottom. So now just guess what I'm trying to do. Like I'm going to cut this out. I'm trying to cut out using solid difference, like the first option, the first tool which I used. So I need to create a cutout of this. So I'm going to create like a cap hole here again. So using this cap, the lofted one without scale, like this is with scale and without scale. Now I'm going to scale it in only one axis, scale and so I'm going to scale it in one axis. I'm just doing this because like I just need to cut it out, so it should be a little more bigger in one axis at least, so that it is easy for me to cut. Usually like it doesn't mean you need to scale this, you can try to cut it like that, but I just for safer side I just cut it with scale. This is like scale 1D, like so you see, like so now I can cut this out very like with it's, and now I can cut it out with confidence that I don't create any mistakes. Sorry, I need to connect this here. Now when I turn it off, I got the outside frame which I was looking for. Where to do it. Now I'm going to join like a group. So now we got it. So let's hide this. Let's take this over here. Let's create a product over here. These are the final outputs. So and at last we merge everything. So now we got the center horizontal frame. Now we need to create a like a how to say let's create another like vertical sub vertical curves right now. So what I'm going to do is same procedure which I did to create these curves, but in this case instead of using the line between these two curves, I'm going to use it between these two curves. So like I use curve here, like I create a curve. Now I'm going to divide curve. So the same process like creating a curve then projecting it. So I create 30. So 30 is because like for example in this line you have like 10 and there should be two sub curves between each surface. So it's like 10 plus 20, so it's like 30 curves. So you can create a expression over here so that it connects with that number, but I'm not doing here to avoid a lot of confusion. So I created the points. Now I'm going to like curve closest point maybe. I create the point. Now I'm going to pull the point towards the curve. Down a few curves. This, if I'm not wrong, yeah, this is the curve. So we have two curves right now. Like what I'm going to do is I'm going to create a line, the same concept. Let's hide the points and now let's project it. Project. No, this is like project. I want project on surface. Project curve surface. Now wireframe. I just hide it so that I don't use this curves here. So we created the curves which we want, and right now we're going to do the same. We're going to use the curve here. Before we are going to do this, let's see how much. See, I don't need this. Just simplify. Okay. So I'm going to use perpendicular frame. So you know why I'm using this to create 0.51 and when multiplying data, so it creates a frame. And like you will be like, why we didn't use reparameterization? So we need to reparameterize the curve, and in this case we are going to rotate plane. No, we are not. Sorry, I don't want a rotate plane in this case. So I want something like, what can we use? Like we can use align plane here. So like so I'm connecting the frame over here, and the frame should be aligned in unit Z direction right now. So I create unit Z. So now let's create rectangle. The same, let's create a panel. Panel is so useful. You can you can input values, you can input expressions, and you can use it for seeing the output values. So panel is so helpful for me. So I create X, and now minus 0.25 to 0.25. My number lock is not working. I don't know why. Sometimes my number lock is not like it turned off. So we create this. We are going to do the same process. Keep one cross section, then that's okay. So we created this. Now we are going to cap this, and we cap this, and now we are going to create cap. So let's turn this off, and let's turn everything else on. So this is done. Now we can see like this curve has been overlapping here. What we can do is we can type list item over here, and let's create series. Like this is like one. Is it 0, 1, 2, 3? Let's say it starts with 0, 0, 1, 2, 3. So it should like be 3 step. So let's see the output. 0, 3, 6, 9, like something like this. That's good. Let's flatten this so you can see like like so what you can do is like it's like you can also use skull in it. Right now I'm just playing. So you can see like I just selected the center. I just use lift item. So I created 3 because I know like 0, 1, 2, then it's 3, then 0, 1, 2, then it's 3. So 3, 4, 5, 6, and 7, 8, 9. So it's your choice to do it like however you want. You can use skull pattern. Like what you can do is like I'll show you. False, true, true, false, true, true, true. Underline data. I need to flatten this. So false is like it won't select it. Then true is like it gets selected, or else you can type 0. So in binary values, true is like 1, 0 is like false. So it's up to you. Whatever step you want, you can create it. So we created the sub elements like sub vertical. I don't know. You just call whatever name you want. So and now we created this. Now we are going to create the opening for the like a door and the outside payment, and then we are done with what I think. If you want, you can add more. It's up to you. So I'm going to use curve on surface to offset. Sometimes the command goes actually to offset on surface. So now I just need to connect the curve towards this list, and like the surface, obviously the surface will be the loft. Actually there is like I created this surface somewhere here. I don't know, yeah, it's here. So you can use the surface here. Why? Wow, so to say. But why? Let's go and give it a loft. Why not? Maybe let's try giving a value maybe. But why it is not working? because it asks a curve and I give a curve. Yeah, why not? Let's go. Seriously, bro. Wait. Let's give a curve from here. We got a curve. Technically, we got a curve which we think okay, offset on surface, okay, curve, surface is like this. Let's flatten this now and flatten the surface. I don't know, like offset curve on surface. Offset this and we're going to create a surface. So we're going to connect the surface. Curve offset field. Let's give the value maybe like some values. Let's give a negative value. Yeah, it works right now. So we got a for the if the positive it goes below there is no surface, right? So that's the problem. So the same way we are going to create the same like 8 maybe. So we have two curves. We are going to loft this. Okay, and as you see, we lofted this. Now we are going to offset surface. Offset surface, or this offset surface has like both side offsets. So I just need a both side offset like 0.5, and this side should be negative minus 6. So let's keep 0.5, 0.5. 3 off. And now I'm going to bring the bit up which we created at the first hidden, so that I don't want to create a lot of confusion over here. Now it's solid difference here, so I create right here. So this is a solid paper which we need, so now it's been cutted. It is the one which we need this. Now what I'm going to do is like the curve which we use, like this curve. So I'm going to use like maybe dash lines, yeah, dash pattern or like sub curve. You can use whatever you want. Right now I'm using dash lines, which most of the people doesn't use. Maybe I give like pattern of 5. So you can see the dash pattern over here, like you can create a dash. Now I give it 10, so this is the line which I need. Whereas like you can also use subcurves, like it creates it select a part of a curve by using construct domain like 0 to 1 and just reparameterize it. You can create using subcurve also. It depends on people to people. Now before we use them, let's see. Okay, let's simplify. Now I'm going to use list item here, and I'm going to, so you can see like you can see each is as different branch. You can create 3 branch to select one branch out of the path. But instead of that, I just do flatten so that I work with indexes. So I create one here. So let's create one, and then I give shift list. Let me create another. Then I just give flatten. Then I give shift list again. And now I'm going to select this so that the lift is being shifted, so I can select the nearby curves, and I can create an opening. I'm planning to create an opening for now. Let's create loft and curves. And you see we created the curve. The same concept offset surface, but I want to offset input surface, which is easy to cut. Like I'm going to do this as minus x because I'm going to use like both sides. So 0.6 over here and 0.6 on the other side. And you know what I'm going to do before that, I'm going to make it solid so that I can cut it down. Okay. That's it. I just bring it down. Where's the, yeah, there it is. Solid difference. So cut it here, then here. So you can change the value accordingly, your choice. You can cut it darkly, like it's up to you. But for now, right now, let's keep it like 1 for now. So now we have a graph. So now instead of using this, we move this aside and we use this. So now when you turn it on and when you turn this off, now we have something similar which we need right now. So at last we are going to create a pathway around the dome structure. What I'm going to do is I'm going to use the curve for this again. Where is this curve? Yeah, I'm going to use this curve again, and now I'm going to offset this curve outside with a value of 2 maybe, or like more than 2, why not? So what I'm going to do is I'm going to use this curve and this curve. So what I'm going to do is endpoints. I'm going to do the endpoints again. Let's create the point. Let's select the point start over here and start over here. So we have these 2 points. Now I can project this point over the curve so that I can cut the curve. Like I can create a curve line and I can extend the line and I can cut it or trim it how I want so that I can create this curve. I can do region. So what I'm going to do is I'm going to use curve closest point. So I'm going to use this and I'm going to use this curve the same way. Now I'm going to use line over here. I'm going to use a line over here and this point over here. So we have two lines for cutting it. Let's do extend for safer side. I create extend curves over here. Control C, Control V. Now I'm going to use rule to curve surface over here. And now I'm going to use the curve, this one and this one. And then I'm going to use rule to surface. So now you know what I'm going to do. Like I'm going to do like let's go to intersection. Where it is? Yeah, we have intersections, and because like I get confused. Like split below. Like we have the bit up here. We get the cutter. Okay. Sorry, I connected in the wrong way. So I'm using Rhino 8 right now. So I get confused because in Rhino 8 the Grasshopper version 2 is really good. Maybe you can try it. The client version. So I'm going to simplify and flatten. And now when I see there's two locally trimmed surface open mirror picture, I'm going to list item reverse list. So now I got this. So now what I'm going to do is I'm going to extract curve from this maybe. So I can extract curve from surface with curve parameter. Now I'm going to do offset curve. Take the value of like 0.1 maybe. It's like a boundary. So now I'm going to fillet this curve. Fillet and radius the same. Let's give this. Let's hide this for now. Let's hide everything for now. We got the fillet. And the same way we're going to fillet this also with the same radius. So I'm going to hide this. I'm going to hide everything. So now we got these two curves. I'm just going to do a simple thing. So what I'm going to do is I'm going to use surface, boundary surface. So boundary surface create a surface for a planar surface. And now I'm going to use again the boundary surface over here. Wait. Something is missing. Yeah. I'm just like turning on the line curves because before it was like turned off. Now I'm going to do extrude. So what I'm going to do is like I'm going to create a parapet or something like a wall with a boundary. So I use need to set over here. Maybe 0.15. Let's use the same component, Control C, Control V, then use this. Maybe in the second it's 0.3. And now we are going to do solid difference. So you could have said, bro, Instead of doing this, you could have said like, bro, instead of doing this, we can easily like connect these two curves, and you could have like what you can do is like there's two curves, right? You can do rule the surface here and here. So the problem we face here is this. So that's why, because like it's been filtered in the both sides, that's why I just created separately and created the option. So I just create beat up over here and we got the model right now. Let's move this like let's merge all the components which we have right now. Merge, merge. And let's hide everything so that when we are merging, we'll know what we are merging. Okay. Okay. Now, if you want, you can exactly not this. Maybe this one. You can just like merge it here. So I just hide everything else. Now what I'm going to do is I'm going to break this like group. Like if you want, you can select a layer, but I'm not selecting. I just select default by color. Or you can change it by layer if you want, or you can change it by color. So I just give it by layer. Like you can change the modes, so whatever you want. Let's hide this. Holy shit! Nothing is visible. Change the shit. We got the model. So in this case, so we achieve the model which we really needed. Like let's show preview on. Okay, let's preview off. Preview on. Okay, so we got the final model is done. So the final model is done. So tell me if you have any doubt. Let me know in the comment section. And I hope this video is helpful. Please do the subscribe button. So let's see you on the next video with another interesting factor of Grasshopper. I hope you learn a lot of components in this and you can use it in your own ways. Okay, thank you. Have a good day. Bye bye. See you in the next video.